Definitely. Thank you, Indian Chemical News, for having this discussion. And I believe that from the morning we would be having a lot of discussion and deliberation around for the sustainable, inclusive, and resilient agriculture, and moving towards taking all the industry, government, and the other stakeholders all along. While we are talking about the moving towards Viksit Bharat and Amrit Kal is continued, we will be achieving the 100 years also after 24 years. And so, what are the challenges before the Indian agriculture? First of all, the first challenge what we see is the increasing population. As per the United Nations, by 2050, currently we are 1.43 billion, and we would be somewhere around 1.67 billion. So to feed that much of the population, how much ready we are with all the solutions, either the agrochemicals or with the technologies. The fragmented and small land holdings. We believe that 60 to 70%, around 60% population is still dependent on the agriculture, directly or indirectly. Out of these 60%, 80% farmers are small and the marginal farmers. And the land holding is decreasing day by day. The next is the climate change. This is the data of the ISRO of last year, this year, May 24, wherein more than half country, the temperature was above 40 degree, and it has reached up to the 48 degrees. Why I am sharing these challenges? Definitely, it will set the discussion agenda also, how we'll be sharing our views on the same and developing the new technologies to address the same. Decreasing water level. 54% of India faces high to extremely high water stress. And the day by day, it's decreasing also. Decreasing soil fertility. With the increasing output, high-yielding varieties, more and more production and the productivity, there is a decrease in the fertility also. And UNESCO has warned that by 90% of the land fertility could decline by 2050. And the next and the last one, what correlate with the discussion as well as the crop protection industry, is the resistance development against the various pests. The crop has to defend and with more than 30,000 different weeds, 10,000 of different species of the insects, and the fungi and the diseases and the molds. So around these, the discussion, and to resolve and keeping in mind all these solutions, the CropLife India, which I am representing here, it has the network across the globe in 91 countries. And globally, CropLife members spend on an average INR of 50,000 crores annually to provide safe, secure, and sustainable solutions. These are the 17 members of CropLife India in India, and who are more focused on the research and development. These are some of the key activities we focus upon, from the policy advocacy and the stewardship, engaging with all the stakeholders, whether the government or the farmers or the industry or the co-partners or the co-associations also. Policy advocacy, anti-counterfeit, stewardship program, progressive regulations, and the communication and the outreach are the key focus areas of the CropLife engagements. And CropLife India, if I talk about this, it can be summarized with the presenting 4 R's majorly, which represent the industry as well as the concerns also. The first R is the regulation. It's definitely is governed by the government, regulated, but it's highly regulated. Even from the production to the distribution, for the sale, even after the sale, this is regulated. A person can carry a full bottle of the pesticides or the crop protection product, but can't carry the empty pesticide bottle or the crop protection bottle. So that is, as per the MOEF guidelines, it is designated as a hazardous. So after the sale, it is also regulated, it's highly regulated. The second R is the research. Academia and the industry are involved. Industry, as I mentioned, that definitely more than 50,000 crores annually spent on the same. So research is involved. The third R represents the revenue. Now we are, the Indian market is of the crop protection product or the agrochemical is somewhere 8 billion crores. We export, we are the second largest exporter of crop protection products with the export of 5.5 billion. And the globally its market somewhere the 80 billion. And first is the China, and the second is the India, and the third one is the USA. Welcome, Kalyan bhai. Though we started without a moderator.
Stuck in a video.
Yeah, I can understand. Thank you. So third is the revenue. how it helping the economy to grow, how it helping the socio-economic development for the farmers also. And the fourth R is the connected to the farmers and response of the users. Amongst and containing all these challenges or these regulations, how the CropLife India or the crop protection industry sees the focus on the what the Yogesh has also asked, the precision agriculture or the digitalization or the cutting edge technologies. All are the part of under the cutting edge technologies, whether the precision agriculture or the AI or the digitalization. If I talk from the industry's perspective, there the crop production products are having AI, active ingredients, then the formulations, then the uses and the supply and the whole value chain. Another is the biologicals. There we are focusing computer chemistry formulations, different active ingredients which have been grown into the past from 1960s. Earlier, the use of the pyrethroids we were using more than 100 kg or the 1000 kg per hectare. Now, which has decreased to the sum of 10 to 50 grams per hectare. That is the development of all these digitalization or the precision technology into the for the crop production for developing a more resilient or the sustainable solution or active ingredients. Diagnostic apps have been developed, technology applications have been drawn, and the codes, apps developed by the mobile apps, they are also the applied technologies. And from the drone, since we are globally present in the 91 countries with the best of the global best practices, we have been advocating to bring the drones, and we are the very much active partner with the government for formulating the policies for the drones. And now the government has issued the SOPs for various products, for various crops to use the drones. And the data management for farmers at the farmers level, or the government is also developing a IPMS, though I am not authorized to share much more about, but my industry members are already aware that they are also into the process of developing and collaborating all the inputs from the industry to develop a system to have digitalization of all the inputs, to have a record of import as well as the export, and what are the uses of various molecules in the country, so that accordingly the policy can be framed. This is the result of the different research being done by the member companies or the crop protection industry. In 1960, 10 kg per hectare was the active ingredients was used. Now, which has reduced to somewhere the 10 grams. And apart from using the quantity, the toxicity level has also decreased in the 40 years. From very high toxic to low toxic to moderate toxic, and now we have very low toxic molecules available in the country. This is the result of the research. Though we have more detailed discussion after the moderator will raise a question, this was just for the information and for setting the context of the discussion, how the crop protection industry is facing and what the efforts they are contributing. I will just add that every technology is not known up to the success, is not known as a successful until and unless it is used by the farmers. So all efforts should be done either with the by the government or by the industry or by the academia or the research, how beneficially it could be for the farmers and it can be adopted by the farmers. Some of the challenges of the crop protection industry see the complex registration process, which we all face, and we do have deliberation and regular discussion with the CIB, RC or the ministry level also. Rising R&D cost also, with an increased need for the innovations. And policy support for the promotion of new technology. This is a very challenging, and we have been submitting and various aspects of the how the new technology is brought to the country, how it will benefit not only to the farmers, not only to the industry, but also very much to the farmers. So future efforts are towards ease of doing agriculture and safe farmers and safe food. With this, I would close my this presentation, and I would request Dr. Kalyan Goswami to take over the discussion. Thank you.
Thank you, Durgesh bhai. My sincere apology. I could not make it on time. We had our governing council member and governing council meeting, and I got stuck there. Anyway, you have started, and very good presentation as usual. So let me introduce the panelist. Durgesh has just spoke. He is the Secretary General in CLI, and he got around 26 years experience in public policy and social sector advisory. Very learned and dynamic personality. Thyagarajan sir is there, although there's no need to introduce him, but it's a formality. He has got so much of experience in the field of agrochemicals and crop protection. अगर उसके साथ 10 साल जोड़ देंगे तो मेरा उम्र हो जाएगा. He has got, I think, around 46 years experience. 44 years, and he has worked in different multinational organizations, and also he used to be the technical head in CLI, and he was our technical head also in CFI. And then Kuldeep Singh ji, chairman and managing director, nahi aa paaye. He got stuck in Supreme Court, I think, Supreme Court. He called me in the morning, and mera purana mitra hai mere saath, and he is the director marketing, Shashank ji. He is MBA in management and masters in agriculture science, specialized in horticulture. He has got around 28 years experience in the field of marketing and strategic management. We'd like to hear more from you. And you know me, I am Dr. Kalyan Goswami. I am the Director General of ACFI. Earlier, I used to be the Director General in NSCI, National Seed Association of India. Before that, I was the Secretary General in food processing, and got around 32 years experience. So, it's good that, Durgesh Bhai has started the presentation, not wasting time. I'll straight come to Tyaga sir. Before that, let me say a few words. The situation in agriculture now in India was not the same in 1947. If you look back in 1947, the biggest challenge in front of the policymaker was how to provide food to 43 crore of the Indians. And you all know that, under the leadership of M.S. Swaminathan, the initiative of Green Revolution was taken. And the Green Revolution as a pilot, it has been done in Punjab, Haryana, Western UP. And that time only, the use of, I should mention the contribution of Norman Borlaug also. That's highly required. We appreciate him, we respect him. And from that point of time, from food deficit country, India has become food surplus country in 1997, not now, long back. India has become food surplus country, and I don't want to go to the history. The history says that we used to even import, wheat, we used to import paddy, we used to import all the agricultural, commodities. The situation has completely changed. But the biggest issue now, let me talk about the issues. India typically, we have almost 82% are marginal farmers. Marginal farmers, they have small land holding. And they are still, they are still using the conventional agriculture, methodology only. They are yet to get the benefit of the, technological development. And I also come from Northeast, I know the situation very well. So if you typically look, only few states like like this Punjab, Haryana, Western UP, Karnataka, Tamil Nadu, Maharashtra to great extent, and Gujarat. They have got, they are in a position, their farmers are in a position to use the new technologies. The rest of the country is not that, it's not that, capable of using new technology or a high yielding variety seed or, developed fertilizer or insecticide, blah, 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 all these things. This is one part. Second part is that, what is happening due to urbanization, the land holding is coming down further, drastically coming down. The population has gone up to, I think, 145 crore. Although it has been said that, the TRF, total fertility rate, is low, so, maybe 20 years down the line, the population will be stagnant. That's a different thing altogether. So due to urbanization, the land holding is coming down. And secondly, agriculture is no more profitable. We have to accept the fact. We all are sitting here, we all are suited-booted people. I don't see any farmer is there. Although I just, anyway, let us not go to any debate. So the farmers, if we bring farmers, they can speak more on their woes, So we may not understand their woes that much also. There are a number of issues. So there's a big question how to make farming more remunerative, more cost effective. That's a big question. So now I'll straight go to Thyagarajan sir, as because we all call him sir only, as because he's like our mentor. He's a scientist. Sir, can you please share with the audience, and it will be learning for me also, that what are the innovation happened in the field of crop protection, and how do we see Indian, crop protection industry maybe 20 years down the line? As because today also we had a lot of discussion in the governing council, and the question has come from there only. So I'd like to hear from you. Sir. Yeah, you can.
A very good afternoon to all, and esteemed panelists, ladies and gentlemen. Thanks, ICN, for the opportunity and for the few words of introduction as well as for the contest setting both by Durgesh and Dr. Kalyan. In the context of the title that is there, I will try to go a little more technical into the cutting-edge technologies because it's all an overarching principle under the precision agriculture. And today a lot of developments are taking place with over $6 billion products getting off patent, 30 to 35 molecules. But the funnel of new molecules is getting dried up, and with the result, there is more thrust on biologicals. So my talk to you, I have the slides, but I was told that slides will not be there, it should be a talk. So my talk to you would be in four baskets. One is on the chemistry formulation development, the biologicals, the genetics, and the innovations that are happening on a miscellaneous factors which are very interesting across the globe and in India. In another 10, 15 years, this could be the domain in which everybody would be talking. So if you come down to the chemical part of it, you have essentially a lot of developments happening in the formulation development, because products which are sort of off patent and which are having a high tox profile, by just changing the formulations, you can make the products much more safer to use. And this is ZC, ZE, all the formulations which are now coming up, and nano formulations where at low tox profile, low dose, and extremely highly safe to the environment. I'm just going to go through fast because of these four buckets. There are many points, so please bear with me. The second is the hybrid formulations, which are a combination of the biologicals and the chemicals. And as we see already, we have difenconazole with tree oil, difenconazole with Pseudomonas cultures, and where the ratios of the biologicals are more and the chemicals are less, and these have been commercialized also by the companies. The third research area that are going on is the replacement of the chemical solvents with plant derivatives, and Pangria company has already patented its plant extract in 75 countries where you have toxic solvents being replaced with plant extracts, and another 2-3 companies are already in the field. So there is a move towards replacing chemical solvents with plant derivatives. The fifth is the mineral, lot of essential oils are now being used. Thyme oil, carbical oil, and all these oils which are now going to be in the formulation, and these give a boost, sort of a synergy to the further enhancement or activity or productivity of the compound, especially seen in insecticides and fungicides. And these oils which I mentioned, and in India, a lot of research is going on dill seed oil also. You have plant derivatives like kojic acid, which is a UV protectant. At the same time, a very good synergistic for synthetic pyrethroids and carbamates being used in the formulation so that the volatility of the compound can be reduced. You have sulforaflavescens, a product, which is the matrine compound, which is now extensively used in China. At low doses, very good for insecticides. You have chitosan being now introduced in the India and tested in India. Chitosan reduces the active ingredient content in the formulation. At the same time, twofold enhances the activity of the product. Brassicioids, which are already in India, but now a lot of research going on as they are extracted from the pollens of the brassica plants, are wonder stimulants, and these products will in future rule the arena. Australian companies are now working on IPM concepts of having formulations which could attract parasites and predators for mealybug, aphid control, and these two companies are shortly going to launch by January, February, these products in Australian markets, where you could reduce the spray these chemicals, parasite predators could be attracted, and they would reduce the pest intensity. A lot of work is going on resistance management in using deactivation compounds. Resistance management are 5 types of resistance in an insect. 2 are very important, penetrative resistance and metabolic resistance. So when you spray a chemical, the chemical before it gets into the site of activity gets detoxified by a certain chemical the insect releases. How to nullify that chemical inside the insect body, research is going on, and 2 Israeli firms have brought out chemicals which could sort of change the resistance to synthetic pyrethroids and OP compounds. So the entire focus in chemistry is on green chemistry and safer formulations. If I move to biological, and there are many, I'm just listing the key ones. If I move to biologicals, which is the direction in which all the countries are moving, taking a pledge by 2030 or 2035, bring 50% less of chemicals. The first is the plant microbial interactions that are taking place at the root level, at the plant level, where the microbes are exchanging signals, communications, handling stress tolerances. The second is the bioherbicides. We have bioinsecticides, biofungicides, bioherbicides especially are now being commercialized, and 2 or 3 of that have been launched, especially in the African sanctuary Kaziranga, where you have invasive weeds like mimosa and Latina camera, and these particular bioherbicides are being used. So in a non-crop area, first probably the bioherbicides will become very, very prominent, probably even replacing some of the synthetic glyphosates and the glufosinate in future. The most important direction in which secondary metabolites is working upon, these are exudates of organisms which have more potency than the original compound, and secondary metabolites of Pseudomonas and all have excellent control measures, and this will be the future. Unfortunately, in India, we don't have registration guidelines, and the associations have been seeking for it. The world is looking at is the peptide chemistry. The developments of peptide chemistry in the world is so advanced that today 18 products are commercialized. 2 of them which are doing very well is the spider venom, which has been launched. The venom from the spiders has been launched by a company, and they are making good money at low doses. This is no MRLs are required, exempted for pre-harvest intervals. The second is the bee venom. Aphacin in bee venom causes a very, very, very good bacterial disease management. At the same time, in India, right at this very moment, the bee venom products in the health industry has been launched for arthritis control and is available with clear directions of what and how it acts. So in health conditions also, these peptide chemistries are moving in. The other field in which is the biometabolic activators. Now, biometabolic activators are from the compounds from the plants that have been derived and they have been sprayed into the plant. So they enhance the metabolism of the crop. And a company called Ferti Global brought in the NUV technology, which has facilitated enhancing the metabolic process of the plant, thereby managing drought and saline stress situations. You have the phytoalexins, which is a very interesting field. Phytoalexins are small phenolic compounds in the plant, like you have in the human body cell. When you do a blood analysis, you have lymphocytes, you have different cells. Similarly, you have one cell which is very, very low percentage in the human blood, which is the natural killer cell, NK cells. Now, the Japanese have extracted the NK cells, they multiplied 10,000 times, and they put it back into the human body to manage cancer. And these are very important. This is a concept developed in Kyoto. Similarly, the phytoalexins in the plant chemistry has come in, wherein the first one was viniferin, the phytoalexin, which has been commercialized by that time Ron Polonc, which is now sold as Elliott, as a product in the market. But now everything, whether it is a potato plant, late blight, whether it is a tomato, late blight, every plant has small quantities of phytoalexins, tuberine, or phytoalexins. And these are now being commercialized through NMR technology, and they will be free. With the result, the chemical usages will come down because you are going to enhance the plant immune system. The most interesting field in which work is going on in India and abroad is bacteriophages. Bacteriophages are derived out of the viruses from soils, and they are multiplied, they are made into formulations and sprayed for the best bacterial management control. In India, the ICR centers as Raipur and all are working on bacterial management disease. Internationally, 4 formulations have been launched, and these viruses get into the bacteria, control them. Lastly, if not in the biological segment, the most interesting work is going on in the seaweed, both in the nutritional side as well as in the agrochemical side. With India's 8,000 kilometers of sea coast, the seaweeds are being extracted, combination of seaweeds, because they have over 20% of protein in that. So these amino acids and all these are being combined together to make into super formulations. And this field will bring in the use of biologicals to our safe food. I now move on to the third field, which I said was genetic, which is genetically modified organisms, which is very clearly where I think, as we know in India, still it is on a question mark, but all over the world, the GMO is catching up. But more interestingly, the non-GMO approach, which is called the Clearfield technology, launched in India on the directed-seeded rice through IMI-tolerant rice herbicide by IRI and few other companies. There are 7 such crops where you can do the IMI-tolerant varieties, which are commercially launched by BASF. And this Clearfield technology, the tolerant gene to back crossings, has been a big hit in the international markets. And in India, work has started on mustard. The most important is the genetically modified mosquitoes, which has been launched in California, which has been by EPA. This facilitates to bring down malaria and other sort of infections in Africa. It has been tested in California. It has been tested. A company called Oxitec has brought in the genetically modified mosquitoes. And this field of management of public health is catching importance using genetic engineering. If you see precision agriculture, which Durgesh touched upon, the most important is robotics. And robotics is being handled in a very different way, right from transplanting to harvesting, to many other fields of robotic science is being, as much as that today research assistants are now being employed as robots in many international labs. From 6 in the evening to next day morning, it's the robots that are doing the various lab activities. In Bangalore, in Indus Valley School, you have the robots which are playing important role in teaching. If you just Google out and see, it's the robots that are handling the classes in the thing. So artificial intelligence under precision engineering is gaining a lot of importance, and the fear of the Americans when artificial intelligence came, that what will happen was soon drowned, because they found that artificial intelligence brought the real aspects of the market into the classrooms, because students, when they walk out of the classrooms, they find the world outside is new. Artificial intelligence bridged the gap. So the big use in artificial intelligence and data analytics is always the educating file. And this is going to be a big field in this scenario. Coming to some of the very interesting miscellaneous technical developments that are taking place in this world, you have a lot of work going on post-harvest management, because you have over 2 lakh crores of perishables being destroyed. So this extracts from the crab shells and from plant derivatives are being used, and 2 Israeli firms are giving samples in India and are testing it for post-harvest disease management. The Australians have launched what is called as the BVT technique, bee vectoring technique, wherein the bumblebees are put in the cages and they pass through solutions which have got biological fungal control solutions. The bees go sit on the flowers and they spread on the flower the chemical, with the result there is a boost in production as well as disease management, and this is commercially now being done. In Australia, nuclear technology has been released and approved by the Government of India for soil management, for increasing the carbon content and converting the salinity of the soils to the acidic range. In the waste utilization, a very interesting developments are taking place. We know coconut and other usages can be done, but for example, in sugarcane, the bagasse is being used for extracting and replacing in moisturizers. All big companies like L'Oreal and all that, the moisturizers that you put, had a compound called pentylyl glycol, which was a known human carcinogen. This has been extracted out of the sugarcane bagasse, and a pentyol compound has been done so that these mixtures are being used on the well-known brands. And this is towards the safer side. And in India, the bagasse are being exported to France all the way for pentyol extraction. In BASF, as corn has extracted the polylactic acid, where you have found the compostable plastics being done through the polymer, and this PLA from has been branded as Ecovio, being sold in India as compostable bags. You have the silkworm pupae in Mysore and all. After the silkworm threads are extracted, the pupae which is boiled, from that they extract amino acids, the omega-3 and 6 fatty acids, importantly the chitosan. So a lot of waste utilization measures are being taken. Pomegranate, which we throw out the rind, now they have found that there is a product called urolithin A, which is very good for colorectal cancer, and so now the extracts of this. Parthenium, a weed which is grown all across here, they have found the word parthenin, which is used for insect control, and an alkaloid for prostate cancer. So lot of and clothing and for extraction of colors from fruits and vegetables into drying. This technology is well accepted in India. So many developments are taking in the waste utilization sectors. Importantly, Government of India has put in few lakh crores in green hydrogen, which is a Haber-Bosch process. UP government has set up 1 lakh crores for a thing wherein renewable energy is being used to put into and derive hydrogen from the water, which gets in with the nitrogen in the air to form ammonical fertilizers. And 1 lakh crore is UP government's thing for any field of green hydrogen utilization, and all the state governments are now getting into it. Worldwide, it is very, very advanced. Soil remediation, carbon trading we spoke about in the morning, is becoming a very important trade, where Australian companies use volcanic ash in the soil to improve the carbon content. Another biological fungus called Metarhizium anisophilae, and these products are put into the sugarcane plant near the ground, and these spores absorb the carbon from the atmosphere, enhancing the carbon content in the soil. So the soil remediation measures are taking place, and thereby the carbon trading procedures are being done. In tox studies, the animal killing is being stopped, and the alternate models are being done. Right now in Jamia University, the discussions are going on for alternate model for testing, because killing of animals has been banned in cosmetics and other fields. So on a whole lot, there has been a development sort of thing. I would stop here because there is a lot many to say. But all across you find cutting edge technologies coming up, because this is going to be one of the biggest industries. And as per what some of the leading research, McKinsey and others have said, that all these cutting edge technologies, if they rightly get adopted by 2030 or 35, $95 billion would get added to the Indian economy and make Indian agriculture also, as well as for the companies working on it, a win-win situation. Thank you.
Many thanks, sir. Once, after one round, I'll come back to everyone with second question, right? Now I'll come to Shashankji. You are, you're working in HIL for almost 3 decades?
No, different organizations. HIL last 5 years.
Okay, you are. Okay, so, HIL, it was formed in 1954, if I'm right. And why it was formed? To produce DDT. So from DDT, Gamaxin, bleaching powder, now endosulfan, now where are we? Would like to hear from you. And secondly, I am really keen to know what is this LLLINS technology? Yes, because wherever I go in the village, I hear a lot of appreciations, you know, and only HIL is doing that. So, sir.
Thank you very much, Kalyanda. First of all, I will extend my thanks to ICN for giving the opportunity. Yes, it is very much correct that HIL was established in 1954 with the objective to produce the DDT for eradicating the malaria from the country. And till 2022, we have produced this product. Agriculture, I think long back it was banned. But health department, this product was using for controlling the malaria. And this is a success story, I can say. Now almost we have eradicated malaria from our country around 74%. And as per Government of India target, by 2030, we have to complete the 100% eradication of the malaria. Later we came to in agrochemical because we seen that DDT production is going down, and later we have diversified into agrochemicals. Yes, agrochemicals also we have set very good examples, producing the technicals. As on date also we have around 6 technical plants with us, mainly located in Rasaini, Maharashtra. Right now, 2022, I have proposed, HIL has proposed for restructuring of the HIL. Because we were having 3 units. One was at Kochi, Udyog Mandal. One formulation plant was there in Bhatinda. And third, we were having at Rasaini, Maharashtra. So the manpower was there, but we were not producing the DDT. So we have requested government for the restructuring. So right now, government has approved the proposal, and we have closed down these 2 units. And whatever technical plant was there with the Udyog Mandal, Kochi, we are transferring to Rasaini. So in coming days, after a year, you will see that HIL will have a single unit with us and with the 6 technical manufacturing facilities. Yes. After agrochemical, what? After agrochemicals, already HIL has gone into the tie-up with Unido. And first we have developed alternative to the DDT. Because this project was started in 2010. Under that, we have developed 3 products. One was the LLIN, and second, this BTI for larvicide of this malaria, and third, neem-based product. LLIN already we have commercialized. Is it a long-lasting insecticidal net? Before 2010, if you will see, this concept was there in the country, that the pesticide was pesticide solution and net was dipped in that, put it into dry place, dried it, and they will use it for some 6 months. Later this technology has come. Why not this pesticide should impregnated in the thread itself? So we have ventured in that technology, and successfully we have taken from the CPET. Now we have our manufacturing plant of master batch at Rasaini, where with the HDP and LDP, we are adding this synthetic paratherides called alpha-cypermethrin, 0.667%, and we are making the master batch. And this master batch we are giving to the downstream vendors. These already develops across the countries. They are making the threads, and out of threads we are making these mosquito nets. These mosquito nets have a unique feature, like in a life cycle is 3 years, 20 times they can wash, and after washing only they have to kept it for a day. Once again it will be generated. If mosquito touch these threads, they will kill. And if they come inside also. So this is a kind of one barrier this technology has developed. Ki at any cost, those mosquitoes are carrying malaria via this disease, they will be killed. So this is the overall LLIN, and yes, we have just last year introduced one farm project of United Nations, where we are developing some bioproducts, and you will see in coming days HIL will have a very good product with this regarding the bios, like trichoderma, BTK, like this. Thank you, sir. Thank you.
Thanks a lot, sir. As such, I have, deliberately have asked you the question. I come from Assam, and this technology has really got very much popular there. And you people are doing a lot of CSR activities, So many thanks for this initiative. I'll come to Durgesh Bhai, as because you are heading CLI, and you have, I think, now 18 members?
17.
17 members, okay. 17 members, and they are all, larger organization. Or I can say that some of the largest organizations,
Yeah.
right? And working in the policy level. So if I typically look at the crop protection industry, what are the policy initiatives, being taken up by CLI? And we are jointly working, no doubt. So you can share with people that what are the policy initiatives being taken up by, CLI, and what are the roadblocks, There are a number of roadblocks.
Yeah, thank you, Kalyan bhai. Definitely, as I earlier also said, a technology cannot be considered as a successful unless and until it reaches to the ultimate consumer or the farmer. So in our case, definitely in the agriculture, when we are looking for every technology developed through various cutting edge technology or the precision agriculture, what we call, or uses of the drone, unless and until it is adopted by the farmers, we can't say it's a successful. And for the adoption of these technologies by the farmers, our extension system or the support system should be very strong. Currently, we will see that after this lab to land, what we earlier used to have, the extension system, that has collapsed. But it requires a lot of policy support. From the industry, if I share the one example of the drone, when the drone was launched, and in many of the countries where the CropLife network has its presence, the drones were used for the pesticides or the crop production products. But in India, there was some hindrance, there was some misconception or some different perception to use how it will be used not in the for the agriculture, but can be used in using some other, creating some dropping some bombs. It was also discussed in the meetings that it can be used in some different ways also. So we shared our best practices. We shared we brought all that technologies, but sometimes the perception before the members as well as the industry himself become a roadblock. Like we talk about some of the neat technologies, unless until our other co-members of the industry are not agreeing to those new technologies, it's become very difficult for the government also to form the policies. We have seen in many of the other parts also, as previous also, and for the drone was also there. We had a lot of deliberations. Recently, we also did on some of the regulatory matters. We brought in some of the international experts to have their views and how their countries are doing and what are their apprehensions, how it can be resolved. That was discussed in detail. We did a workshop on the crop grouping, though it's not a part of the precision or something, but definitely it's a part of the advancing towards the better technologies or the better regulatory policies also. So if we can take all along with all the industry members, it become easy for the government also to take a decision and to form the policies. So if I definitely for the drone or either for the other technologies, what we have done, we have discussed a lot of discussion with the stakeholder, engaging the government as the industry members and as well as the farmers. So how it has benefited, we do a lot of stewardship activities. Like Thyagarajan sir has told how many new different technologies are coming and the new chemicals and the molecules, active ingredients and the formulations are developed. To develop a new molecule, now the Indian members also will agree who are into the R&D. Sometimes 10 to 12,000 crores are spent to just to develop one molecule, and that too from 10 to 12 years also. So if a molecule is developed, it will definitely have a better efficacy, better low toxic level also, and better efficiency also. So if all the other member or the industry also agree, it's become easy for the government to take a decision.
Many thanks, Durgesh bhai. As such, like in a democratic setup, there will be opinion, there will be counter opinions. We have to go by that. But good thing is that last almost, I think, 2 years, all the 4 associations are jointly working, and we are trying to sort out the differences. And in many aspects, we could achieve the success. See what happens in government level, because I come from government setup, so I know that the government level, you are also from government. So the policymakers or the bureaucrats, they always like to divide and rule. So I think in India it has started in 1905 when Bengal was divided. And from that time the, divide and rule things are going on. So I just share with you that we are working together. And you are right that technology cannot do everything alone. The policy should be supportive. And very often we see that the policy comes out like bolt from the blue, even we are not ready. And then we start running from here and there and everything gets jeopardized. But some good things are there also. I mean, this policy arena for last 34 years. Earlier it used to be more confusing. Now at least some clarity is there in last 3 decades. That at least even government is, government has become objective driven. Industry has become objective driven. We also know what is to be done, what is not to be done, right? So anyway, good developments are there. I'll come to Thyagarajan sir. Sir, you talked about peptide chemistry, you talked about, biometabolic activators, and yeah. I also got to know that seaweed. I had the impression seaweed can be used for biostimulant also, but how it helps in crop protection, you have explained. But I see you have talked about the good things only. Good things are always, sounds good, motivating. But what are the issues? There might be issues, might be roadblocks, right? And, what do you think that what industry should do? As because, the biggest challenge is that, again, I'll come to the debatable issue of data protection, and Harish Mehta Sahab would be unhappy with me. So let me not enter in this debate, right? But, see, even investing in R&D, there has to be return on investment, right? So would like to hear from you.
Thank you, Dr. Kalyan. Very rightly said, because there are all these exciting technologies that are coming across, which I spelled out, and I spelled out just, if I have to tell you, just 20-25%. There are so many slides, over 80 slides, which says the whole world is bringing on innovations, including India, but in bits and patches. So across India, when we take precision agriculture encompassing robotics or machine learning or digital and data analytics, everything is happening, but at a different speed and different things. So there is not one sound policy. So I first touch upon the policy adequacy. Before that, I would like to say that today we are 39 number out of 133 countries in the Global Innovation Index. We are 42 in the Global Patent Index. We have over just 51 as such R&D GLP recognized labs, and less said the better of the NABL accredited labs. In a country like India, with so many states and so many, we are still way back as far as what basic infrastructures or basic inputs are required for either global innovation or patenting. Many of the institutions, I was there in the NADAR institution in Chennai, which is very big and addressing 1,000 engineering students. Many of them doing excellent work on startups, doing excellent work on agri-related implications as well as engineering on robot and health and all that. But they were clueless about patent, the rights to patent, the data privacy. Some of them were virtually crying that they casually mentioned their ideas and that ideas were robbed by the seniors and they developed it and they had influence, they got it done. So one way what you spoke about data protection, I'm not talking about it, but in general for innovations that come out of the startups, especially in the industry, this is a must and data privacy has to be there because absolutely without that, a whole lot of energy and time is spent on these efforts. So today on a policy education issue, a lot needs to be done because everything is patchy. Our syllabuses in the agriculture universities are no way connected with the reality in the ground. The lab to land program, as you rightly said, has disappeared. The scientists have been told you publish more papers, you get promotion, you get into higher jobs. They are not told that if you do this work and relate it to the field level, you will be recognized. So the direction is on publication of papers. The students in the universities, the syllabus still remains the same and nothing. I was there recently in one of the agriculture universities and they had no clue of any recent in digital or robotics or artificial learning, machine learning or traceability. The word traceability was new to them. So the question arises that where do you change the syllabus of the students because they are going to be just coming out of the campus not knowing and they get into jobs and then they get frustrated. So on a policy issue, a lot needs to be done, number one. Number two, when you come to the startups, India has, as of the end of last year, 127,000 startups covering all fields. Agri-related startups was only 2,800 as per the figure of the Commerce Ministry. Now, imagine these startups, 2,800, not one single unicorn. There are 100 plus unicorn who are earning over $1 billion, but not a one single field guy who can stand up and say, I did it from the agri sector. They are all working, many of them frustrated, financial flows are very, very slow. The question they are finding it is how to go about the whole process because connectivity, the last mile connectivity or whatever it is still lagging and startups still need a lot of support. The third basket on which I find and here that is where I'm saying the government policy should be startups as in the Insecticide Act where the interpretation and its implementation in state and central are different. The startup find the rules in states are different from one state to another and what center says is different from the state level. So there is no common understanding as much as the Insecticides Act in this country. The third is the farmer basket. When you come to farmer basket, see the demography. We have 650,000 villages, 787 districts, 15 agroclimatic zones, over 15 crore farmers. The education levels are all different. The biggest is their behavioral resistance to adopt new technologies. So they don't want to move in because there is a big trust deficit. Seeing is believing and that is not happening at the local levels. So the movement towards creating FPOs, farmer producing organizations, the channel flow of financing and implementing, adopting blocks and showing the benefits of all these new technologies, then only it will take up because already the CI in its study has said that over 15 crore farmers, nearly 3 crore plus families will migrate by 2030 from rural to urban because the children are not interested in agriculture. So unless you change the entire scenario and make it workable at the field level, as you said, where the farmers should see and adopt, I think it is a big challenge, but every challenge is an opportunity, and I think that is where the government should look at it. Thank you.
Thank you, sir. As such, like young generations are not interested in agriculture. We always say, till that time, it is not becoming profitable. It is not becoming remunerative. It's not bringing money. No one will get involved to it. Anyway, I have a question for Abhishek ji later on, after 5 minutes. As because, like he was talking about research and development. So research and development, R&D has become more like relax and dream for agrochemical industry. Abhishek ji is the youngest governing council member in ACFI. He is very outspoken. I would like to hear from you. But let me go to Shashank ji now. Shashank ji, you have already tied up with PI industry, right? Do you have at the back of your mind to have such type of tie-up with other organizations?
Sure. Because everyone cannot be perfect at every time. So these are the tie-ups always will be beneficial for the organizations. Suppose HIL is having a wide network across the country, and right now we are operating in 22 states of the country. So those organizations are weakened in some south. So we can utilize HIL network for their marketing. So for this kinds of, we started the fertilizer. Even we are not in a production, but we have tie-up with all PSU companies like NFL, FSCT, IFCO, and we have taken the product from them, and some state has been allotted to us, and successfully we conducted. Every year we were doing around 200 crores of business with this trading. So yes, I am open for any kind of MOU with any other organizations, and if they have some new technologies, they are not penetrating the market, we can do. Yes.
Thank you, sir. We'll take one comments from Abhishek ji and one question only, as because like I have 4 minutes time. एक ये दे दीजिए उनको अभिषेक जी को बेटा माइक दे दो. So my question is, Abhishek ji, is, like precisely that, like RDP is not there, data confidentiality is not there. Looking at that scenario or reality, already Mehta Sahib is looking at me, like we always fight on RDP anyway. So looking at the reality, whether, like this agrochemical industry is keen to do R&D or investing huge in R&D, is that going to give the return on investment, and how much it's really essential at this point of time?
So when we speak about R&D, we all know that there are majorly 6 MNCs who you can call innovators, apart from the Japanese players. Apart from the Japanese players, we can say all Japanese players and 6 MNCs who are the innovator of the product. Now, what is the language or the definition of R&D in India? It's basically about improving the processes of the approved or already existing technology, and how we can do the contract manufacturing. Then that is exactly what the session next, which I will be speaking on. Of course, R&D, we all know, is very, very crucial, but the kind of input or the kind of investment which is going in R&D in India is, in a way, you can say minuscule as compared to China. And majorly, the technology transfer comes from the innovator. And that is the reason why, barring 1 or 2 companies, nobody is able to innovate a molecule in India. However, the innovation of molecule has recently started in China also, because all the companies had a gala time in last 10 years. So of course, for making one product, we need, you can say 500 to 600 crores, then maybe 10 to 12 years, and after a lot of things, the new product comes into picture. But as of now, Indian companies don't have that strength, let us be very honest. But investment in R&D can only help us to do more of CDMO, rather than developing a new molecule sees a little distant future as of now, in my true comment. But nevertheless, we, in collaboration, what we were talking about, that can be done. But single Indian company doing that seems tough in today's scenario.
So, anyway, Thyagarajan is from PI, and PI is doing that. They are working, like...
Yeah, PI has been the company at... Yeah, PI is the only company that has sort of brought in a new molecule which is there, and now, as you rightly said, the investments are high in terms of data generation, global acceptance, but it is focused on it. Over 900 scientists work on the discovery platform, but it is a challenge, and that already, and few more are in the anvil. So that is, and rightly said, Indian companies in India put in less than 2% of their profits on R&D. Even if they scale it up, it is always a challenge unless conditions are very ideal. Thank you.
Thank you, Thyagarajan sir. Only one question. We have 1 minute left. Only one question. Is there any question to our panelists? If there's no question, then we will just...
I will then add on something
Sure,
to
sure.
yeah. So you asked also about the policy roadblocks. So just for the information of the forums, across the globe, we do have more than 1,300 molecules developed. But in India, around 330 molecules are only registered. These are some of the regulatory challenges before the industry also. There is not transparency or the proper stakeholder consultation also for many of the major decisions. And that too, for the industry has to go either forced to take a legal route, and that lot of money or the time, efforts or energy wasted into that. That energy and the time can be utilized for the benefits of the whole farming community. This is the some of the regulatory challenges and the policy matter decision. Then the interpretation of the different laws also by the center or the state level. They many a times, since the agriculture is a state subject, they take their own decision without in consultation with the central or with the better interpretation of the Insecticide Act 1968 or insecticide rules 1971. So they are some of the roadblocks or the challenges before the crop protection industry. If there is a proper consultation, stakeholder consultation, transparency and science and science and reason-based policy decision, it would help for the industry as well as for the adoption and them to focus more upon the farming community for the adoption of the new technologies.
Thank you, Durgesh bhai. We'll stop here, and many thanks to the panelists.